Here's example 14 with establishing trig identities. So again, if you want to copy this packet to follow along with, check the link in the video description. So you can click that link, open this up, and print it out if you'd like. So cosecant to the fourth of theta minus cosecant squared of theta equals cotangent to the fourth of theta plus cotangent squared of theta. Okay. So we'll go back to our general process here. So always start on one side, try to make it look like the other side. And apart from that, there's no general strategy, but usually start with the more complicated side. So here, they're actually almost the same as far as level of complicated goes. So here, maybe the left side's a little more complicated because it has a minus instead of a plus. So let's start on the left side. But you can actually start on the right-hand side and do almost entirely the same steps. But we'll only do it on the left-hand side. So if you'd like, you can start on the right-hand side, do almost exactly the same things as what we do, what we're going to do here. So anyway, let's start with the left and go from there. So cosecant to the fourth theta minus cosecant squared of theta equals, so not a whole lot we can do here, but let's maybe try and factor, because cosecant squared and then cosecant to the fourth, so that's like cosecant squared times cosecant squared, right? So let's pull out a common factor of cosecant squared of theta and then times the quantity. So if we pull out a cosecant squared, what's left is another cosecant squared. And then if we pull out a cosecant squared here, what's left is just the minus 1, okay? So now we see, okay, we have a bunch of squared or trig functions, okay? So if we think about, okay, cosecant squared, is that related to any trig function that, or identity that we know? So Pythagorean identity, cosecant squared, okay, we see that cosecant squared is cotangent squared of theta plus 1, okay? Well, let's maybe somehow use this identity to get rid of all of our cosecant squareds, because what do we want? We eventually want cotangent to the fourth of theta plus cotangent squared of theta. Okay, so what we want to do is convert all of our cosecant squareds into cotangent squareds, and we can do that using this Pythagorean identity here. Okay, so here's cosecant squared of theta. So right away we can just directly say cosecant squared of theta exactly equals cotangent squared of theta plus 1. Okay, so let's just substitute that in there right away. So cosecant squared of theta exactly equals cotangent squared of theta plus 1. Now, what about cosecant squared of theta minus 1? We got to transform this into cotangent somehow. Well, what we can do is say, okay, cotangent squared of theta plus 1 is cosecant squared of theta. So let's come over here off to the side. Cotangent squared of theta plus 1 is cosecant squared of theta. So what I have is cosecant squared of theta minus 1. So let me take this previously established identity. I can mess with this any way that I want to make it more useful to me, right? But for the identity that we're establishing, we can only work on one side. Just start on one side and manipulate only that side. Okay, but with the previously established identity that we already know, we can manipulate that however we want to use it to make it more useful to us. So cosecant squared of theta minus 1, well, let me go back to this Pythagorean identity here. Subtract 1 from both sides. And what do we have? We have cotangent squared of theta equals cosecant squared of theta minus 1. So this cosecant squared of theta minus 1 exactly equals cotangent squared of theta. Okay, so cosecant squared is cotangent squared plus 1. That's Pythagorean identity. We can manipulate the Pythagorean identity, subtract 1 from both sides to get that cosecant squared of theta minus 1 is cotangent squared of theta. Okay, now what? Now we distribute. Okay, there's not really much else to do besides distribute. And then we're going to end up with cotangent to the fourth of theta. Okay, cotangent squared times cotangent squared is cotangent to the fourth. And then plus 1 times cotangent squared, which is cotangent squared. And that's exactly what we wanted, cotangent to the fourth of theta plus cotangent squared of theta. That's what we have. It's exactly what we wanted. Check mark, we're done. Okay, so just to recap what we did real quick. Cosecant to the fourth of theta minus cosecant squared of theta. We factored out the common factor of cosecant squared of theta. Okay, so we pulled that out. And then we said, okay, we have a bunch of cosecant squareds. Can we somehow convert those into cotangents, which is what we want? And yeah, we can do that using the Pythagorean identity here. Cosecant squared and cotangent squared are related by this identity here. So if we use that to get rid of all of these cosecant squareds here, then we're good to go. Okay? And that's exactly what we did. We ended up with this using the Pythagorean identities, and we distributed, and we ended up with what we wanted. Okay? Now again, we could have gone backwards. We could have started with the right-hand side and ended up with the left-hand side the exact same way pretty much. Start with cotangent to the fourth theta plus cotangent squared of theta, factor out the cotangent squared, you end up with this. And if you're going to start with the right-hand side and go to the left, then you're going to say, okay, I have cotangent squareds, I want cosecant squareds, what can I do? Well, I can use this identity, okay? So really, you can start with the right-hand side and do pretty much exactly what we did. Factor, use the Pythagorean identity twice, and distribute. So here we factored, used the Pythagorean identity once here, once again here, and we distributed. Well, if you start with the right-hand side, go to the left-hand side, it's exactly the same thing. Okay, factor out a cotangent squared, use the Pythagorean identity twice to get rid of the cotangent squareds, convert them into cosecant squareds, and then distribute what you end up with, and you'll end up with the left-hand side after that. Okay, so a couple different ways of doing example 14, but either way it's the same thing. Factor Pythagorean identity twice, and then distribute, and that's it. So that's it for example 14. Example 15 coming up next.